That's gravity?
And yeah, that's how much you weigh, is how much.
That's a G-force.
So it's
In a
like
sense,
this,
yeah.
Milky Way.
But when you talk about large masses of body in vacuum,
But I'm just saying,
masses.
as far as gravity itself is not, it's not electrical, it's not magnetic, because it affects
it's
other.
a radio wave.
No, because radio wave is still electrical. It would have to affect something that's made of metal.
Well, it's not necessarily electrical. Everything's on the electromagnetic grid in the universe.
It's all
The universe runs on electromagnetic.
outside today.
But there's certain areas of the universe that don't run on electromagnetic.
Get the punchline.
Yeah, but see, but
Like black holes and
Get the
pulsars.
punchline.
gravity is nothing electrical.
No.
That's
The
what I'm
heat
trying to say.
generation is still electronical.
It's like the paddle.
You know.
Well, I know, but
Heat exchange, plasma exchange, Kelvin degree plasma, hydrogen explosions. The explosion causes it to, the gravity still fucking wants to crush it in, so then it explodes again, and then it crushes in, and it, like stars do that.
Right.
Because it'll burn off so much, and the mass will start to friction itself and have an instant explosion again, but the gravity of itself will keep it in a little ball.
yeah.
And so sooner or later it implodes on itself and becomes a black hole, or it implodes on itself and bursts into
We got some more paper.
a nebula.
Right.
Turns into a dust cloud.
Okay, but I'm just saying, as far as the gravity.
Right, but the gravity is mass and mass. Sure.
And it has to be, I estimate it has to be spinning. It has to be spinning.
I think it had to have had some other source of the whole.
Well, look at all the smaller planets you go by. Okay.
Yeah, but if you look at the nebula, it all just blows up into a dust cloud. And eventually, over another billions of years, the same billions of years it took for that star to blow up, it's going to take another billion years for it all to go and compact into its own little planetary whatever, or it could be, burning things or whatever.
Right.
And compact and blow up again.
Okay. But you take some of the planets in this solar system and you look at how many revolutions they make per
So are you driving?
whatever hours.
Right, they're all spinning.
They're all spinning at different speeds. And the ones that spin at the lower speeds have the least amount of gravity in them. And the ones that spin higher, have
Jupiter and Saturn. Jupiter and Saturn have gravity because they're big.
Right, but also at the rate that they're spinning, they're covering, well, the Earth is 25,000 miles in circumference, or whatever. Okay, and one spin is moving pretty dang fast.
That's all you got to do. Keep your hands down.
Relative to size.
Right. They're moving, that one revolution is moving that outer diameter of that planet at a pretty fast rate. That's what I'm saying about the gravity being related to the spinning effect of the planet. Because all of them have different gravity, all of them have different rates of revolution, sizes.
They're all gyroscoping at their own pace.
So they're all running, or?
And the fact that gravity on Earth has never been upset by the amount of radio signals that are all of a sudden popping up all over. It has never been upset by anything electrical. Lightning
is far-reaching.
Lightning, okay, lightning is electrical. If gravity was electrically oriented,
lightning is just a frequency. Light is a different frequency, and so is X-rays. X-rays aren't electrical. We can just measure them with an electrical device. We can create them with an electrical device. X-rays are in their own spectrum, just like light is in its own spectrum, and